Hi, in this video, I'll explain the concept of an interval, explain the interval notation, and how it's applied in confidence intervals in statistics. The easiest way to think of an interval is to visualize it as a segment of the number line. Here's a number line. And if we think that some number p is between 0.3 and 0.8, then that means p is somewhere in here. In this portion of the number line between 0.3 and 0.8. That's what an interval is. A portion of the line. Now, here's 0.3, here's 0.8, and p somewhere in there, then that means p is greater than 0.3, or 0.3 is less than p. Now, looking on this end, we see that p is less than 0.8. So we can write this inequality. Because this p here is in common, we can collapse the two inequalities into one, and we end up with this. And it's called a compound inequality. When you write a compound inequality, you have to pay attention that it has to make sense all the way through. In this case, we see that this part here is true, that 0.3 is less than p. This part here is also true, that p is less than 0.8. And this part here, all the way from the 0.3 to the 0.8, must also be true. 0.3 must be less than 0.8. I have seen people write something like this. That is an incorrect compound inequality. Because if a number is greater than 19, it will not be less than 4. And if you look at it from the far left to the far right, then definitely 19 is not less than 4. So this is a bad compound inequality. Don't write like that. All right, so using a compound inequality is one way of writing an interval. We're describing the interval as all the numbers between 0.3 and 0.8. Another way of writing an interval is using interval notation. And it consists of parentheses. We open parentheses. We write in the number that's on the left endpoint of the interval. So the left endpoint of the interval is this number, 0.3. We put in a comma, and then we put in the number at the right endpoint of the interval. So that's 0.8. And then we close parentheses. Parentheses, left endpoint, comma, right endpoint, close parentheses. Now, as an aside here, if you're in algebra, then your teacher will go through open intervals using parentheses like this, but you will also learn closed interval, and it comes with braces, square braces, or half open, half closed. So parentheses on one side, a brace on the other side, or it could be parentheses on one side and brace on the other side like that. So those are the other variations on the interval notation that you may see in an algebra class. In statistics, we don't go into these cases because for continuous distributions, which is the context of all of these intervals, they're all the same. So traditionally, we just use parentheses as an open interval and we don't worry about it. Another point here is that this notation could be confusing for some people, because remember that we identify a point on the XY plane the same way, with parentheses, a number, comma, another number, and then close parent. They look the same, but they mean different things. So the context of what we are talking about will help you identify if we're talking about an interval here or a single point there. Right? Pay attention to the context. Now, how does an interval come up in a statistics class? It comes up in a situation like this. Suppose we want to determine what percent of the voters support Chris Rock for president.
I'm out here. Uh-oh, Richard. Oh, wow. Wow.
What percent or what proportion well, if you watch news reports or read news reports and people talk about the surveys that they do, and they say that so many percent support this candidate or that candidate, those reports always come with a margin of error. When we do statistics, because we have to generalize from a sample to a whole population, we can never be certain of anything. So let's write this down. Stat results are never certain. Good news is the uncertainty, the degree of uncertainty, can be measured mathematically. The results themselves are never certain, but how uncertain they are, those can be determined pretty accurately. There are two things that affects. One is called the confidence level. No useful result will ever have 100% certainty or confidence. If you want 100% confidence, you have to give a result that is so widespread that it's useless. And the second thing is margin of error. And this is where the interval notation comes in. Suppose we did our survey or our polling, and we find out that 35% of voters support Chris Rock for president, plus or minus a margin of error of 3%. In statistics, we prefer to write these percentages in decimal numbers. So 35% would be 0.35 and 3% would be 0.03. Let's look at the number line. Well, 0.35 is right here. So we think it's 0.35. We call this a point estimate. Margin of error of 3%. That means 3% up from here. Anywhere in here is possible. But also on the low side, everything down here is also possible. Anywhere within 3% up and 3% down is possible. So this is your margin of error. And therefore, the integral from 0.32, which is the low side of 0.35 minus 0.03, to 0.38, which is the high side from 0.35 plus 0.03, anything in there could be the proportion. And so our confidence interval could be written in interval notation as 0.32, comma 0.38. It could be written in compound inequality as 0.32 less than p less than 0.38, but it could also be written in this form, in the form of point estimate plus or minus margin of error. These are the three different ways of writing an interval in statistics. You can see that the first two methods are similar because they both give the endpoints. This is the left endpoint, and this is the right endpoint. The first two methods give the endpoints, whereas the last method gives the point estimate and the margin of error. One of the things you should be able to do is to go back and forth between these three formats. If someone gives you an interval notation, you should be able to write it as a compound inequality. If someone gives you a compound inequality, you need to be able to come up with a way to write it as point estimate plus or minus margin of error. You can see that between the interval notation and the compound inequality, between the two of them, it's kind of easy because they are both the same numerical values, just write in a different format. Whereas going between those two and the plus or minus kind of notation is different. There will need to be some sort of calculation, yeah? So let me show you how to do that. Going from the blank plus or minus blank to interval notation or compound inequality. If I have 0.35 plus or minus 0.03, then what I do is I compute the plus, I compute the minus. And then put in the correct order from small to large. It says plus or minus, so first I compute the plus 0.35 plus 0.03. And the minus 0.35 minus 0.03 is equal to 0.32. And then I put them in order. 0.32 is smaller, so it comes first, comma 0.38 and parentheses. So I got my interval notation. Now, how about the compound inequality? Well, I know the 0.32 is on the left, the 0.38 is on the right, and they have two inequalities. But now I need what letter to go in between. In a stats problem, you will need to determine what kind of values, what kind of symbol goes in there. It could be a proportion, in which case you put P. It could be a mean, in which case you put mu for population mean. It could be other things, right? Whatever the question is talking about, that's the symbol you put in there. So it's one more thing than the interval notation. So that's how you go from the plus or minus symbol to the other two. Now I'm going to show you how to go from this kind of notation, either compound inequality or interval notation, and convert it into a plus or minus kind of notation. If we're given the interval first, can we convert it to the form of a point estimate plus or minus margin of error? To do this, it helps to visualize the interval on the number line. Here's the number line. Somewhere here is 0.32. and somewhere over here is 0.38. That's our interval. How would the point estimate in the margin of error fit into this interval? Well, the point estimate is in the middle of the interval. And then it plus or minus the margin of error to get to the endpoints. So there's a plus margin of error here, and there's a minus margin of error there. Because it goes up and down by the same distance, the margin of error, the point estimate is in the middle. How do we find the middle of two numbers? We take the average. The average of two numbers will be in the middle of them, right? The point estimate is equal to the average of the endpoints. 0.38 plus 0.32 over 2. 0.38 plus 0.32 makes 0.70. Divide by 2 is 0.35. Point estimate is equal to 0.35. Now, there are multiple ways of calculating the margin of error after we got this. So one way is that this side here is the margin of error. It's a distance between the 0.38 endpoint and the point estimate. The distance between 2 points is the difference between them. You subtract them. So the margin of error, one way we could do it is to take the right endpoint minus the point estimate. That's one way of doing it. Well, you notice that there's a second margin of error on the left. So it could also be equal to the difference between the point estimate and the left endpoint, between the 0.35 and the 0.32. And then the third way of doing it is you notice that the whole difference, the entire interval, consists of two margin of errors. There's a margin of error on the left, and there's a margin of error on the right. There are two of them that make up the whole interval. So it could be, so each margin of error is half of the interval. So it's 0.38 minus 0.32, that's the whole interval. 0.38 minus 0.32 is a whole interval. That's two margins of error. If you want one margin of error, you divide by 2. If you carry each of these calculations out, you'll see that they're all the same answer. 0.03, this is 0.03, this is 0.06 divided by 2, which is also 0.03. So 3 different ways of finding the margin of error, knowing the interval. Let's do a couple more examples. Example 3. A 2022 poll estimates that 77% of people in New Hampshire support teaching sex ed in schools with a margin of error of 3.2 percentage points. Write the confidence interval for the proportion P as compound inequality and in interval notation. So we have our P here. That is 77%, but it's not really 77%. It's plus or minus a margin of error of 3.2 percentage points. So 3.2% in decimal form is 0.032. Yeah. So this is 0.77 plus or minus 0.032. Well, if there's a plus and a minus, all we need to do is to plus it and minus it. Yeah. 0.77 plus 0.032 is 0.802. 0.77 minus 0.032 is equal to 0.738. So in interval notation, just put them in order and put them in parentheses with a comma in between. For compound inequality, we put in a couple inequality symbols. And we need a symbol to go in here. So we look at the problem and it says proportion. The symbol for proportion is P. As a matter of fact, the problem even tells us that the symbol is P. So we're just going to use it. We're going to put the letter P in here. And there it is, compound inequality. And last example, example 4. A poll from October 2022 found that between 58.6% and 65.4% of Americans are willing to pay higher energy costs as a price for helping Ukraine against Russia. The confidence level was 95%. What that means is, like all stats results, even with the margin of error, we're not even certain that it's within those two left endpoint and right endpoint. We're only 95% certain that it's somewhere, or only 95% confident that it's somewhere between those two numbers. Compute the point estimate and the margin of error. Again, for this kind of problem, I find it helpful to actually draw the number line so you can visually see where the point estimate is and where the margin of error is. Draw a number line. 58.6% is somewhere, and in decimal form is 0.586. The other endpoint is 65.4%, which in decimal form is 0.654. The point estimate is right in the middle, and the margin of error is here and here. Therefore, the point estimate is the average of these two numbers is equal to 1.24 divided by 2, which is 0.62, or 62%. The margin of error, there are 3 ways of doing it. I can go from the high point to the point estimate, which I now know to be 0.62. Or I can go from the point estimate to the low point or the left endpoint. Or I can take the difference of the whole thing. And all of that constitute 2 margins of error. So I need to divide by 2 to get to 1 margin of error. Either way, I get 0.034. Point estimate is 0.62. Margin of error is 0.034. I put it together, I get 0.62 plus or minus 0.034. But actually, the question didn't ask for that. The question asked for the point estimate and the margin of error. All right, I hope that helps. If you have any questions, ask in the comments and I'll answer them. Like, share, and subscribe for more contents. And thanks for watching. Bye.